Section 10.4, other angle relationships in circles. Okay, so we did central angles. The central angle vertex on the center is the same measure as its intercepted arc. Then we did inscribed angles, has its vertex on the circle with the sides of the angle being chords, and it is half the intercepted arc. Okay? So, this same idea of it being half the intercepted arc is true when one side of the angle is tangent to the circle. Okay? So that's our next theorem. It says that if a tangent and a chord, what's a tangent and what's a chord? Right? Tangent, the line touches the circle in one place. The chord passes through the circle in two places. So if a tangent and a chord intersect on a circle, then the measure of each angle, because you're going to see two angles now, is 1/2 the measure of the intercepted arc. Okay, so yeah, you're going to see two angles, okay, which is different than with the inscribed angle. Okay, so what we're looking at is here is your circle, a tangent touches, and a chord, okay? So where it touches, we're going to call point A, and then we're going to put a point out here so we can talk about the two different arcs. So we have angle 1, which is this angle. So the measure of angle 1 is half the measure of arc AB. And then angle 2 is this one here, okay? And it's going to be half of its intercepted arc, which happens to be arc ACB or BCA. Okay, because that's the outer arc. So vertex is still on the circle, then it is half of its intercepted arc. Okay. Then the next two theorems, okay, so 1013 and 1014. A little bit different. Your angles aren't the center, but they're not necessarily on the circle either. Okay, so to look at them, if you have two lines that intersect a circle, okay, you can have two lines intersecting on your circle. You can have two lines intersecting inside the circle. And you can have, well, that's not even close to a circle, two lines intersecting outside the circle. So here, it's intersecting your circle, okay, and the lines themselves are intersecting outside the circle. You know how, right? Last lesson and theorems 10, 12 tell us how to find an angle and an arc measure if they intersect on the circle. Now we're looking at these two in 1013 and 1014. Okay? So theorem 1013 tells us that if you have two chords intersect on the interior, then the measure of each angle, you actually end up having four angles here, okay? So these are two chords intersecting inside, four angles, okay? So each angle is 1/2 the sum of the two measures of the arcs intercepted by the angle and its vertical. Okay, so again, here is your circle. Okay, 2 chords. We're not going to have them be central angles this time. Okay, because that's its own lesson. So we're going to talk about these 2 angles, angles 1 and 2. And here's A, B, C, and D. Okay, so angle 1, it's 1/2 a sum. Okay, so here's angle 1 out here. So its intercepted arc is arc DC. And the vertical angle would be this one, so it's this intercepted arc. So 1/2 BC plus, not BC, sorry, CD plus AB. Angle 2 is very similar, okay, but it's 2 different arcs, so it's half the sum. So this is angle 2, its intercepted arc here is BC, and its vertical is AD. Okay, that's when your 2 chords intersect inside the circle. So it's not at the center of the circle, it's just they're inside, so the angle is half the sum of the 2 intercepted arcs. So if you're talking about this angle, it's half the sum of these 2 arcs. Okay? All right, last theorem, and then we'll do examples. So 1014 deals with that last case when they're intersecting outside the circle. Okay, so when you have a tangent and a secant, 2 tangents, or 2 secants that intersect outside. So they intersect on the exterior. Then the measure of the angle is 1/2 the difference of the measures of the intercepted arc. Okay, so our 3 cases. So we have a tangent and a secant. Secant goes through twice, tangent goes once. Okay, so here's A, B, C, and here's our angle 1. Then when we're looking at 2 tangents, okay, so tangent, tangent, they intersect in one place, right? We're going to put a point Q out here, and here's P and R, and our angle 2. And then the third one is 2 secants. So here's a secant, here's a secant. Call that angle 3. Here's W, X, Y, and Z. Okay? The angle is 1/2 the difference of something. Okay, difference means subtraction. So it's the difference in the 2 arcs formed by the angle. It's always going to be the bigger minus the smaller, okay? So out here, angle 1, first arc is BC minus AC, which is the other intercepted arc. Okay, angle 2. Technically, it's the full circle, but it's a difference, so it's not half of 360. So here's the big arc, so it's PQR. Minus this smaller arc, which is PR. And then for the 2 secants, you have this arc and this arc. So it's going to be arc XZ minus arc WY. So notice that all of these angles are half something except for the central angle. Intercepted arcs are half the arc with the vertex on the circle. When it's 2 chords intersecting inside, it's half the sum. And when they intersect outside, it's half the difference of the arcs. But it's always 1/2 something. Okay, so So our theorems, right? So here's our circle. Line M is tangent to the circle. And we have a line out here intersecting as T and point S. And we're going to say this is 102 degrees, the angle. So we want to find the measure of arc RST. Okay, well, it's intersecting on the circle. So the measure of the angle, so we're going to call this, just say the angle, is half the measure of the arc. So the angle is 102 degrees, which is half the measure of the arc. So multiply by 2, and the measure of the arc is 204 degrees. Okay. All right, another one. Here's our circle. Line BC is tangent to the circle. Here's point B and C. And then line BD is here, and point A is out here. We're going to say this angle is 3x degrees, and the arc, I'm going to say the measure of angle CBD is 3x, and the measure of arc BAD is 4x plus 50. Okay, so again, it's the vertex is on the circle, okay? So that tells us that the angle is half the arc. So the angle is 3x, that's 1/2 the arc, which is 4x plus 50. And then we can solve for x. So we're going to distribute the 1/2. So 3x equals 2x plus 25, and subtract 2x. So we get x is 25. Okay, then you can use that to find the measure of the angle, because the angle is 3 times that. So the measure of angle CBD would be 3 times 25, or 75 degrees. Okay, if it's on the circle, it's half the arc. All right. Then we have a circle. Okay, we have 2 lines intersecting inside the circle. We're going to say this is X. That is not the center, okay? Let's maybe draw it so it's clearly not the center. Here's our circle. All right, here is S, T, R, and U. X is here. We're told arc RU is 120 degrees and arc ST is 40 degrees. Okay, so if it's inside the circle, the measure of the angle is half the sum of the measure of the arcs. So arc RU plus arc ST, because RU is this intercepted arc and its vertical is ST. So X is 1/2 120 plus 40. Order of operations, that would be half of 160. So the measure of angle X is 80 degrees. Okay, then we have a circle and we have 2 tangents that are intersecting outside of our circle here. We've got a point T where the tangents intersect are R and S, and then they intersect at point P. This arc is 80 degrees and we want to find x, the measure of the angle. So when it's outside the circle, the measure of the angle is half the difference of the intercepted arcs. So the big arc here is arc RTS minus this arc, so arc RS. Okay, so we don't really know, just by looking at the problem, what the measure of arc RTS is. We do have a full circle. We know this is 80, so this is 360 minus 80, or 280 degrees. And then arc RS is 80 degrees. The difference is 200, and half the difference is 100. So angle X is 100 degrees. Okay, and that is 10.4.